Sometimes we'll have more than one quantifier. For example, if x and y are both odd, then xy is odd. Since there are no restrictions on x and y beyond both being an element of the set S of odd numbers, we can use the universal quantifier. For any x in the set, and for any y in the set, the product is also in the set. What if we have two or more quantifiers? Does the order matter? Well, let's try it out. Let p be the set of prime numbers and z the set of integers greater than 1. Let's compare the statements for any x in z, for any y in p. xy is not an element of p, and the same statement but with the quantifiers switched. So now the first statement says that for any x that's greater than 1, and for any prime y, the product xy is not prime. And this is clearly true. The second statement says that for any prime y, for any integer x greater than 1, the product xy is not prime, and this appears to be the same statement. And this suggests that in general we can switch to adjacent for any quantifiers. Or let's take an there exists quantifier. So let p be the set of prime numbers and z the set of integers greater than 1. Let's compare two statements with the existential quantifiers switched. The first statement says there is some integer x greater than 1, and there is some prime y where x is greater than y. And clearly this is true as long as we choose the right x and y values. And since these are existential quantifiers, we can choose the right values. Now the second statement says that for some prime y and for some integer x greater than 1, we have x greater than y, which seems to say the same thing, so it appears we can switch to adjacent existential quantifiers. And in some sense, if both quantifiers are the same, the order doesn't matter. If they're both universal quantifiers, then we can choose anything we want. If they're both existential quantifiers, we just have to choose the right values. But if they are existential quantifiers, we can always do that. In these cases, we might join the two into a single quantifier. So a sequence of universal quantifiers can just be a single for any x and y, and a sequence of existential quantifiers can be a single there is some x and y. What about negations? Earlier we saw that if we moved a negation through a quantifier, it changed the quantifiers. So what if we had multiple quantifiers? For example, if we wanted to rewrite something like this. So we can move the negation from the statement to the quantifier by changing the quantifier. But what now? And remember, sweep things under the rug. Note that this term here is a statement. That's the whole point of using quantifiers, and we've negated the statement. And we know that we can shift a negation across the next quantifier if we change it. And so we'll shift that all the way to the front. Now, so far, both of our quantifiers have been the same, but what if they're mixed? So let p be the set of prime numbers and z the set of integers greater than 1. Let's compare our two statements. So the first statement claims that for any x integer greater than 1, there is some prime number where y divides x. And clearly this is true. That's kind of the whole point of prime numbers. Now let's take a look at that second statement. This claims that there is some prime y, which for any integer x, y divides x. But that's not true. Regardless of the prime we pick, we'll always be able to find some x where y doesn't divide that x. And so the second statement isn't true and certainly can't be the same as our first statement. And this previous example shows that the order of mixed quantifiers matters. In fact, there's no De Morgan-like rule that allows us to switch the order of mixed quantifiers. So let's take an example. Let f of x be x squared, and let's express as a mixed quantifier. Given any epsilon greater than 0, you can always find a delta where the absolute difference is less than delta, means that the difference between x squared and 4 is less than epsilon. Now, this is a rather complicated sentence this early in the game, but let's break it down. Note that we can choose any epsilon, so we can use a universal quantifier. However, finding delta implies that not all delta will work, so we use an existential quantifier. And finally, the order of the statement implies that epsilon is taken first. And so what we need to write is, for any epsilon, there is a delta where this conditional is relevant.